Here is question 9. This is a new notation, so it says determine dy over dx. So let's focus specifically on this notation. And I just want to explain how this works. So dy over dx is a command. It says differentiate y with respect to x. So you'll notice that on the left-hand side, you do not have the equation as f of x. Instead, you have it given as y is equal to. That means that y is the subject of the formula. You are going to differentiate y with respect to x, which makes sense why we have it as dy over dx, meaning differentiate y with respect to x. So let's go through our 3 preparation steps as per normal. So firstly, we check for brackets, which we do not have, but we do have a surd. So here we've got square roots of x, so that is a surd. We need to change that surd to an exponent. So we are going to rewrite that as -3. And you guys know that the square root of x is x to the power 1 over 2. So square root as an exponent is a half. Then, in the next step, we need to make sure that there are no variables in the denominator. However, we do have a variable in the denominator. Here we have the x squared. We need to get this x squared out of the denominator. So how can we do this? Now, the fact that we have a fraction and we've got 2 terms in the numerator, before we get rid of x in the denominator, let's first split up this fraction. This will make it a lot easier when it comes to simplifying. So we can write this as x over x squared minus 3x to the power 1 over 2 over x squared. So all we've done at the moment is we've just split up the fraction. Now we're going to focus on getting rid of x in the denominator. And I'm just going to work with each term separately on the side so we can see what we get. We are going to use laws of exponents to simplify this. So you guys know you are dividing bases that are the same. You can subtract the exponents. We're going to take the top exponent minus the bottom exponent. Here we have 1 minus 2, which gives you -1. So simplifying the first term, you have x to the power -1. Now let us separately look at how to simplify the second term. Okay, firstly, the -3 will stay there. That's your coefficient. I want to focus mainly on how to simplify the x's. So we've got x to the power 1 over 2 in the numerator and x squared in the denominator. Now again, we are dividing bases that are the same, so we can subtract the exponents. Again, it is going to be the top exponent minus the bottom exponent. That is going to be 1 over 2 minus 2, which gives you -3 over 2. So for your second term, you now have -3 x to the power -3 over 2. Okay, so what we've done is we've simplified, we've got rid of x in the denominator, and I expect you guys to do the same as well. Instead of showing every step in here, for your simplification, especially where you have x in the numerator and denominator, and you're going to use laws of exponents, do that separately on the side, exactly how I've done it. And whatever you get, that is what you're going to write down. So now I want you guys to notice that we've done our 3 preparation steps. We're now going to go on to differentiating. So to differentiate the right-hand side, your coefficient of x in the first term is actually 1. So remember, it is the exponent multiplied by the coefficient. We have -1 times 1, which is -1, and we minus 1 from the exponent. So -1 minus 1 gives you -2. Now for the second term, we're going to take the exponent, multiply by the coefficient. That gives you, so firstly we have negative 3 over 2 multiplied by negative 3. That is going to be positive 9 over 2. We're going to minus 1 from this exponent, so we have negative 3 over 2 minus 1. That gives you negative 5 over 2. Bearing in mind that at the moment your variable is in the numerator. That is why I have it in the 9, next to the 9, sorry. In the numerator, next to the 9. Okay, so you guys notice that we have differentiated. Now the next step is correct notation. We haven't really used any notation yet because we've got y on the left-hand side. Now notice that I left it blank intentionally. I did not write y prime because that is not the way this question goes. The notation that we are working with is dy over dx. So if ever you are asked to get dy over dx, bear in mind that once you differentiate, you replace y with dy over dx. You do not write y prime. So if your question specifically says determine dy over dx, that is the notation that you use once you differentiate. Something very important to take note of. So we have differentiated, we have used the correct notation, and the last step is to have positive exponents only. So we have a problem with both terms. They both contain negative exponents. Working with the first term, to make that exponent, you have negative 2. To make that exponent positive, keep the negative 1 in the numerator, move the variable to the denominator, and its exponent becomes positive. You're going to apply the same rule to the second term. The 9 will stay at the top. The variable moves to the bottom next to the 2, and its exponent now becomes positive 5 over 2. So we have differentiated with the correct notation, and we have positive exponents only in our final answer. So this is it.